Hi, my name is Wouter Emery and I'm the founder of AirShaper. In this video, we'll discuss flow separation. In our previous video, we saw that the air close to the surface will stick to it, forming a boundary layer. But in some cases, the air is not able to follow a certain curvature on the geometry and it will detach or separate. Let's look at why this can happen. When you look at the airflow across a flat plate, as we did in our previous video, the free airstream velocity is quasi-constant. Because of Bernoulli's equation, which states that pressure goes up as velocity goes down and vice versa, this means that if the velocity is constant, the pressure is also constant. This means that the pressure gradient in the horizontal or x direction is almost zero. Also, the pressure inside the boundary layer is actually imposed by the pressure in the free stream velocity or free stream airstream above. This means that the pressure gradient in the vertical direction, away from the surface, is also close to zero. But if the air moves across a curved surface, it will start to speed up and slow down. Take the flow around a cylinder, for example. At the front face, the pressure is the highest as the air comes to a complete standstill, something we call the stagnation point. From there, it starts to curve around the cylinder, speeding up, creating a drop in pressure. Now, as the pressure drops with increasing distance traveled x, we can talk about a negative pressure gradient, which is good. The airstream is actually being pushed forward by the pressure delta, and this helps to overcome the friction generated in the boundary layer, which gradually grows thicker. The maximum velocity is typically reached somewhere around the midpoint of the cylinder, after which the flow starts to slow down again. This means that the pressure gradient is now reversed. It's a positive one, because as we move across the surface of the cylinder, the pressure goes up. And this is what we call an adverse pressure gradient. The flow is no longer driven by the pressure gradient, but actually obstructed by it, because the airflow now needs to flow into regions with a higher pressure. If the pressure gradient in the horizontal direction is positive or zero, as in the case of the flat plate, then the velocity gradient in the vertical direction is a positive one. This means that the further you move away from the wall, the higher your velocity. But if the airflow has to move against an adverse pressure gradient, this will push back the velocity profile, and this reduces the velocity gradient at the wall. At some point, the velocity gradient at the wall will become zero, which is the point where the flow can detach or separate. Beyond this point, the velocity is zero both at the wall, because of the no-slip condition, and at the inflection point, which is where the velocity crosses from negative into positive. Anywhere in between the wall and this inflection point, the velocity is negative, which means you have a backward flow. And this is what we call recirculation. The normal separated or detached flow will now start to surf on top of this recirculation flow, which will increase the thickness of the boundary layer and the wake it leaves behind. And this can have a negative effect on the drag. In reality, shapes are typically much more complex than just cylinders, and the flow can detach and reattach in various locations. Even on a smooth airfoil, the flow can detach and then reattach later on. So it is very much a three-dimensional challenge, and getting it right requires a careful analysis and optimization of the local and global pressure gradients. Also, keep in mind that flow separation can happen in both laminar and turbulent boundary layers. Turbulent boundary layers, however, carry much more momentum and can stay attached to the surface further downstream compared to a laminar one. Just check our videos on golf ball aerodynamics or vortex generators to learn more about it. So that was it for this first short video on boundary layer separation. I hope you liked it. If you did, hit the like button and subscribe to our channel. Thanks a lot for watching. See you soon. Bye bye.